Angular displacement, theta, is expressed in radians. 1 revolution, which is equal to 360 degrees, is equal to 2 pi radians. So therefore, 1 radian is equal to 57.3 degrees. We express the angular displacement as the arc length L divided by the radius R. So theta is equal to L over R. Angular speed omega. Omega is equal to theta final minus theta initial. So the final position minus the initial position divided by t. Angular acceleration is alpha. Alpha is equal to omega final minus omega initial divided by t. So that is the angular speed final minus the angular speed initial divided by t. I wanted to talk to you about the difference between linear and angular motion. If you look, these equations are pretty similar. So in this one, velocity average is equal to 1/2 velocity initial plus velocity final. In this one, angular velocity is equal to 1/2 the angular velocity initial plus the angular velocity final. In this one, the position is equal to the velocity average times time. And for your change in position, your angle length or your change in your arc length is equal to the average angular velocity times time. Velocity final is equal to velocity initial plus the acceleration times time. The angular velocity final is equal to angular velocity initial plus alpha, the angular acceleration, times time. Velocity squared is equal to velocity initial squared plus 2 times the acceleration times the position. This one, the angular velocity, final velocity squared, is equal to the initial velocity, angular velocity squared, plus 2 times the angular acceleration times time. Position, or the x distance, x displacement, is equal to velocity initial times time plus 1/2 the acceleration times time squared. Our arc length is equal to the initial angular velocity times time plus 1/2 the angular acceleration times time squared. So as you can see, these are very similar that you don't really have to memorize the formula for angular. You just need to know what they represent in the angular compared to the linear. Centripetal force. Centripetal force is equal to the mass times the tangential velocity divided by the radius, which is equal to mass times the radius times omega squared, which is the angular velocity. Cut. Centripetal acceleration. Centripetal acceleration, we use the symbol AC, is equal to tangential speed squared divided by the radius of the circular path, or AC is equal to v squared over r. The bob of a pendulum, 90 centimeters long, swings through a 15 centimeter arc. Find angle theta in radians and degrees. Well, my r is equal to 90 centimeters, and which is equal to 0.90 meters. And my length of my arc is 15 centimeters, which is equal to 0.15 meters. So I can solve for theta. Theta is equal to the length divided by the radius, so L over R. So that is 15 centimeters. Sorry. Cut. So the angle is equal to L divided by R. So that is the 0.15 meters divided by 0.90 meters. And that is equal to 0.17 radians. And then to get this into degrees, you're going to take theta is equal to 0.17 radians. There are 360 degrees in 1 radian, and that equals 9.6 degrees. A belt passes over a wheel of radius 25 centimeters. If a point on the belt has a speed of 5.0 meters per second, how fast is the wheel turning? All right, so let's start with our givens. We have velocity or speed, which is 5.0 meters per second. We have a radius of 25 centimeters, that's 0.25 meters. Okay, we're looking for omega, our angular speed. So omega is equal to V over R. So plugging in, we get 5.0 meters per second divided by 0.25 meters. And that is equal to 20 radians per second. Okay, 20 radians per second. A wheel of 40 centimeter radius rotates on a stationary central axle. It is uniformly sped up from rest to 900 RPM in a time of 20 seconds. Find A, the constant angular acceleration, and B, the tangential acceleration of a point on its rim. Okay, so for part A, alpha is equal to 2 pi radian per revolution. And we have 900 revolutions per minute, which is 60 seconds, minus 2 pi radian per revolution times 0 revolutions per second. All divided by 20 seconds. So alpha is equal to 4.7 radians per second squared. Okay, and then for part B, For part B, what we're going to do is, so this was part A. Part B, we are going to take the tangential acceleration, which is equal to the radius times alpha. So that is 0.40 meters times the 4.7 radians per second squared. And calculating that out, we get 1.88 meters per second squared. So putting it in proper significant figures, 1.9 meters per second squared. So that is the tangential acceleration, 1.9 meters per second squared.